The Fort St. Philip region of the lower Mississippi River was altered by a major flooding event in 1973, when a crevasse, or a cut through the levee, formed, allowing fresh water to enter the salt marsh. As a result, that salinity change degraded this once healthy salt marsh and it became open water. The key to restoring this area was to slow the flow of water in order to increase sediment deposition, allowing for the land to rebuild and a marsh to reestablish. Engineers can maximize the marsh building ability of the sediment-filled river water by constructing terraces in this area of open water. Terraces mimic natural deltaic processes and act just like a speed bump for a car. Speed bumps force a driver to slow down when driving over them, just like engineered terraces force the water that travels over them to also slow down. In 2006, 98 terraces were built within the Fort St. Philip open water area under the management of the United States Fish and Wildlife Service and Louisiana's Coastal Protection and Restoration Authority. Each terrace was roughly 200 feet long and 10 feet wide, and the material used to build the terraces came from the habitat itself. Since this marsh was originally saltwater, the soil naturally had higher amounts of salt in it. These freshly dug terraces were too salty to plant freshwater vegetation right away, so saltwater grass species, like Spartina alterniflora, were originally planted on them. Over time, as more freshwater and rainwater entered the marsh, the salt in the soil was able to dissolve into the water, making it more tolerable for freshwater vegetation. Healthy vegetation helps stabilize the terraces and assists in slowing the movement of the water, allowing for more sediment deposition. Terraces can be built in all shapes and sizes depending upon the factors in the area needing restoration. These site-specific shapes can help marshes grow at a faster pace and can also incorporate essential fish habitats. What structures or structural changes are used to restore habitats?